Okay, next go to digital markup and DMU kinematics. Here we need to make the relation with all the parts to movements for movements. So I select assembly constraint conversion. Here select new mechanism and click OK, and here allow to auto create and click OK. Here open this joint. In joint, double click on revolute one. Here select this driven angle driven and click OK. Next double click on cylindrical 3. Here select these two angle and lengthen driven and click OK. Next here last one, the revolute 5. Here select this angle driven and click OK. Now the message came, the mechanism can be simulated, and click OK. 80 seconds. Okay, now go to here kinematic simulation. These commands are used to control our movements of the parts. It can be anything, the rotation and the up and down movements. These commands are used to control those movements. Okay, this one is the rotation with the spin and housing. See here. So we need to give the correct limitation value. So reset it, and the first one, the lowest value is 0 and the highest value is 5 mm. Click OK. The next, this is our nut rotation. So the lowest value is 0 and the highest value 360 mm. The third command is the up and down movement of our hook jaw. So the lowest value minus 25 mm and the highest value is 18 mm. Click OK. The fourth command, this command is with our handle and the spin. We don't need to give value for this command because we already finished with the spin and housing. These two things are same, so I leave it without change anything and close this window. After that, come here simulation and select this mechanism on and click OK. Here change this all positions and close. Here select, click on insert. The value is 0.01 and now play this. Wait a second. Here we can increase the value of this 18. So I give 25. Click OK. Now still we have some gap here, so I give 40 value. it's interact each other. So I reduce the value to 40 mm. It's okay. Forty mm. Okay. Close this window and go to simulation mechanism 1. Change all of its position and close this window. Insert the 0.01 and play this now. That's all. We need to give the correct value for this, otherwise it's not move the correct way. Okay guys, that's all. We finished the pipe wrench. First we modeled all the parts and we assembled. Now we finished our simulation video. Okay, you all enjoyed this video, I think. If you think this video is more useful to you, then don't forget to subscribe to my channel and click that like button. Okay guys, I see you in next video. Until then, practice Catia and see all of my videos. Okay guys, bye bye.